Hi everyone and welcome back. So today we're going to take a look at 4.4. This is simulations. This really isn't in the book exactly the way that we're going to be looking at it. It just briefly talks about it, so I actually pulled the notes from another book that we have. But you can kind of get the gist of it from page 487 in the book if you need to look something up. All right, if not, then just looking at the notes will be fine. I know most of you don't use the book anyway, so if you do need to look something up, just let me know and I can let you look at the other book if you really want to look at it. Go ahead and put your name up at the top. Put your class hour and today's date. And let's go ahead and look at the objectives for today. All right, so for this one, we're going to perform probability simulations to model real-world situations involving uncertainty. Let's see, we're supposed to have two. I think that's just a typo. I think we're only supposed to have one. Okay, so we're going to perform probability simulations to model real-world situations involving uncertainty. All right. All right, so this is one of those kind of non-mathy lessons. It's just kind of like a word and understanding lesson. It's not really things that we're going to be working out or anything like that. So for some people, this comes super easy. For others, it's like, I have no clue what you're doing. All right, so just kind of bear with me. If you need to watch it twice, obviously. Okay, so what exactly is a simulation? So you guys use simulations all the time, all right? And what you guys know them better as is video games, all right? Video games are simulations, right, of events. Okay, it's just things that could happen or things that could have happened, and they're just simulations of a story, all right? So a simulation is an experiment that is designed to model the action in a given situation, which is what video games are, right? Okay, like some of you play Call of Duty or Modern Warfare, those kinds of things, Assassin's Creed, whatnot. All right, so those things are all kind of based on a story of some kind, and those are a simulation of the story of what's happening. All right, so it's kind of like a movie, if you will. All right, so for example, you use a random number generator to simulate rolling a number cube. All right, simulations often use models to act out an event that would be impractical to perform. All right, so let's take a look here. All right, it says a cereal company is placing one of 8 different trading cards in its boxes of cereal. If each card is equally likely to appear in a box of cereal, describe a model that could be used to simulate the cards you would find in 15 boxes of cereal. All right, so for this one, we need to come up with one of 8 different trading cards. All right, so think of a simulation that we could use where we could practice getting 8 of something until we did it 15 times. All right, so think about things occurring. So, for example, you could flip a coin, you could draw sticks out of a cup, you could draw marbles out of a bag, you can make a spinner, you can roll a number cube or a die, as we call it better. You could pick shapes out of a bag. You can, anything you can think of. All right. So what's something that we could probably do easily for getting one of 8 of something? And I would say probably a spinner. Okay, we could draw a circle with our compass, we could cut it off into 8 different sections, and then we could spin it 15 times to figure out which cards we would actually get. Okay, so for this one, Well, let's do that. So we're going to describe a model that we can use to simulate finding 15. So in words, we're going to say we can create a spinner with 8 equal sections. We would label each section to represent one of each card. We would then spin 15 times and record the outcome. Okay, and there we go. So we can create a spinner with 8 equal sections. We would label each section to represent one of each card. We would then spin the 15 times and record the outcome. All right, so instead of going to the store and buying 15 boxes of cereal, okay, that would get expensive because cereal is about $3 or $4 a box, depending on how big it is. All right, so if we have to buy 15 boxes of cereal, it's going to get very expensive quickly. Okay, you're going to spend $60 just to perform some kind of event. Then you're going to have to open all of them, so then you're going to have 15 boxes of cereal open, and you can't probably eat that much all at one time, obviously. All right, so what would be an easier way is we could use our compass. We could get a piece of poster board. We could draw out a circle then. We could cut that into 8 sections off, and then we could color each one a different color, and then we could sit there and make a spinner out of it and spin it 15 times, and we're out very little money. Okay, all we had to do was make a spinner, which is easy. All right, let's try the got it question. It says a restaurant is giving away one of 5 different toys with its children's meals. If the toys are given out randomly, describe a model that could be used to simulate which toys would be given with 6 children's meals. All right, so basically we're going through the drive-thru, we're getting our Happy Meal from McDonald's. There's 5 toys available. What's the chance of getting all of them within 6 tries? Okay, so again, we got to think of something. So we can flip coins, we can roll a die, we can make a spinner again, we can just draw numbers out of a bag, we can do anything we want, okay? So for this one, maybe let's try, let's see, there's 5. Let's draw marbles this time out of a bag, okay? So we will draw 5 different colored marbles out of a bag. Each represents a toy. We will draw 6 times. And record the result. All right, so you could even do this with like Fruit Loops. I think there's 5 different colors, or at least there should be. Like Skittles, there's yellow, there's orange, there's red, purple, and green. I think that's all of them. So you could use Skittles. So you could say that you're going to go get a little fun pack of Skittles from the candy dish and open those up, and then you're just going to sit there and draw out Skittles 6 times. Okay. You could do it with M&Ms. I think there's 5 colors of M&Ms also. So you could use M&Ms. You could use Starbursts. Anything like that. So you could just kind of keep trying different ones. Anything you want. All right, so again, these are pretty well open to whatever you want to do. It's not anything that there's a wrong answer and a right answer. There's some that would make more sense, but as long as you can explain what you're doing with it, it's going to work, okay? All right, let's take a look at example 2. Nope, as far down as we'll go. Okay. Every student who volunteers at the concession stand during basketball games will receive a free school t-shirt. The t-shirts come in 3 different designs. Design a simulation that could be used to model this situation. Use your simulation to find how many times a student must volunteer in order to get all 3 t-shirts. Okay? So for this one, we're not going to actually perform this just because it takes a little bit of time. All right, so for this one, let's see, we drew marbles last time. So let's see what comes in 3s. Let's see, what can we do? Let's draw sticks. That'll be easy enough. Let's just draw a stick. Okay, so we're going to, so I'll try to write this small so it'll all fit. So we will draw 3 colored popsicle sticks. I don't think I spelled that right. I think it's, whatever, spell check it. I don't know, I can't spell it. Popsicle sticks. Each represents a shirt. Oops, now you really can't write. Each represents a shirt. Okay? And then since this is still open and they want us to perform it, we're just going to say what we would do. So we would keep drawing until all 3 shirts would actually come up. So we will draw sticks until each color is picked. All right. Okay, so we've done kind of an experiment like this in the past. If we have time, we might be able to do this one all together as a class. So what we found was some people were oddly enough able to get it in 3, and some people it took almost 10, 12 tries before they finally got all 3 colors to pop up. So again, that's whole experimental wise and theoretical. Theoretically, it should take you 3 tries, right? But experimental wise, it may take you a whole lot more. All right, let's turn the page and let's take a look at the next one. It says, Mr. Chen must wear a dress shirt and a tie to work. Each day he picks one of his 6 ties at random. Design a simulation that could be used to model this situation, and then use your simulation to find how many days Mr. Chen must work in order to wear all of his ties. All right, so again, we can flip coins, we can draw things out of a jar, we can make a spinner. For this one, because it comes in 6s, all right, I would say let's roll a number cube or a die. All right, so we're going to say we will roll a die. Each number represents one of his ties. We will keep rolling until each number occurs. Okay, so this would be something really, really easy you could do. You guys know it always appears like I'm dressing different every day, which really I just figure out how many different ways I can wear stuff with something else, so it looks like I'm wearing different things every day, which I'm really not. I just kind of keep reusing the same stuff over and over. I just don't wear it exactly the same. So for this one, this would be an easy one. So you could go home, you could grab a die out of a board game that you have, and you could just sit there and keep rolling until you finally get all 6 numbers and see how many days then that would represent that he would end up wearing all of his ties. Okay? So that's a pretty easy one. So again, there's really nothing that won't work necessarily as long as you can explain it. So could we have used a spinner on this one? Yes, we could have made a spinner into 6 sections and keep spinning until we hit all 6 sections, right? Or we could have put 6 colored sticks in a jar and we could have pulled out those. We could have did marbles. We could have flipped coins. Okay, we could have done, like flip, or we could have pulled coins out. Okay, like we could have pulled a penny, a nickel, a dime, a quarter, a 50-cent piece, and an actual dollar piece. Okay, we could have did all kinds of different things with it. There's no wrong answer. It's just you need to be able to explain it to where it makes sense. All right, let's look at example 3. There is a 60% chance of rain for each of the next 2 days. Describe a method you could use to find the experimental probability of having rain on both or both of the next 2 days. All right, so let's take a look at this one. So for this one, we need the outcome to be 3/5 or 60%, okay, which is 3/5. So we kind of need to think of something where we could get 5 outcomes. So for this one, let's use marbles, all right? Let's use 3 red marbles and 2 blue marbles. Okay, so we're going to use 3 red and 2 blues. We're going to put those in a bag. All right, so in this case, let's see how we want to do this. We would say like red would be, it will rain. Red represents rain, and blue does not. Okay? So then what we would do after that is we would randomly pick one marble to simulate the first day, and then you'd replace it and pick again to simulate the second day, and then find the probability of rain for both days. All right? So let's see. I think we probably have it already. I guess we'll just say draw marbles and find the probability for each day. Okay, so this one's a little bit weird just because it has that 60% chance thing in there, but don't let that throw you off, okay? All right, let's try the got it question. And this is it. Okay. During the regular season, Jason made 80% of his free throws. Describe an experiment to find the experimental probability of Jason making his next 2 free throws. All right. So for this one, I think a spinner would probably be easiest just because 80%, 80 over 100 would be 4/5. So we need something in 5s. And I think it'd just be easier to do a spinner probably on this one. Okay. So we're going to use a spinner. In which 80% or 4/5 represents, sorry, grammatically correct here, represents making a free throw. One-fifth or 20% represents not making a free throw. And then we would spin twice. All right, so basically what this would look like would be something like this. So here would be my spinner. Okay, I need to break it off into 5 sections. So let's say kind of like that. I totally drew that wrong. You guys know I can't draw, so let's try that again. Or here, I only need it in 4 sections, or 2 sections, I guess, technically. Like that, something like that. Okay, so then if this one spins, so if he spins the dark one, he misses. Okay, is what we would kind of say. All right, so that's kind of what the spinner would look like. So we'd have 5 sections. 4 of them would represent the white, which in this case would be the free throw that he makes it, and the other one would be that he misses it. So we just sit there and keep spinning the spinner, and as long as we didn't hit the black section, that meant we made the free throw. Okay, so when you do this, again, there's lots of different options. Spinners are probably the easiest, although don't make all of them spinners if you can. Spinners are the easiest. You can flip coins if you have multiples of 2. You can do draw popsicle sticks. You can draw Skittles out of a bag, M&Ms out of a bag, Fruit Loops. Okay, cereal. You could just do like regular Cheerios versus the sugar-coated ones. You could do. Let's see, what else did I talk about already? You can use a number cube, a die, and all of that. So you could use all kinds of stuff on there. All right. Just take your time. Just make sure it makes sense. Again, there's really not a wrong answer as long as what you have down actually explains what you're trying to do with it all. All right. So thanks for watching and have a good one. And don't forget to give me a like and subscribe.